This is chapter 5.6, exercises 9 through 16, mostly on law of cosines and also law of sines. The section 5.6 in our book has to do with law of cosines, and also toward the end of that section, using Heron's formula, area equation. And I'm going to go over the odd number problems here, 9, 11, 13, 15. In exercises 9 through 16, solve the triangle. And here we have sides given. We have what we call a side application. And for a side application, we would normally resort to the law of cosines. Let's take a look at this, the sides of this triangle. We have a side of a triangle that's 5 in length. So I'm going to go ahead and make this 5 here. And we also have a side that is 4 units in length, so I'm going to put side C over here in this direction, but make it only to 4 units. And then we have side A, which is 1 unit. Well, just drawing in that direction, we go to 1 unit. Now, can we, with these 3 pieces here, compose a triangle of them? Well, look, you have the short sides 4 and 1 equal the long sides, so in order to have these ends match up, we're going to have to smash this 4 unit length right alongside that 5 unit length and add another 1 unit piece to have all the ends tied up. And by the time we do that, do we anymore truly have a triangle? No, we have a line segment. So if the short sides, in this case C and A, are less than or equal to the longest side, we do not have a triangle. So no triangle exists. I'll just say it that way. And take with you that same logic, looking at that next problem, even though problem 10. Next, we'll go to problem 11. Exercises 9 through 16 solve the triangle. In this case, we do have side C and side A. Now again, this is going to be a side, so normally we would do a law of cosines with this. But A and C are shorter sides. 6.4 plus 3.2 are going to add up to 9.6. And since 9.6 is longer than that longest side of 7.6, we do have a triangle. And so we're going to use the law of cosines. The law of cosines for this one, we're going to take the largest angle first. We have b squared equals a squared plus b squared, plus c squared. A squared plus c squared plus 2ac cosine angle B. And in this case, angle B right here, this B itself I'm boxing in red, is our unknown. So let's go ahead and write the equation with the numbers filled in. We have our long side, which is B, 7.6 squared, equals a squared. Well, a is 3.2 plus c, which is 6.4 squared, minus 2 times 3.2 times 6.4 times cosine of angle B, which we do not yet know. So that is our unknown right here. Now, to isolate this B, the angle by itself, we're going to need to start moving stuff over. Well, the first thing we're going to do is take this 3.2 squared and subtract it from both sides of the equation, and also the 6.4 squared. And so on the left side of the equal sign, we have minus 3.2 squared and minus 6.4 squared. And we cancel out these things here. We have remaining 7.6 squared minus 3.2 squared minus 6.4 squared equals negative 2 times 3.2 times 6.4 times cosine B. And now, what are these negative 2 times 3.2 times 6.4 doing to this cosine B? Well, they are multiplying. So we're going to have to undo that multiplication by dividing both sides by the same thing, which would be negative 2 times 3.2 times 6.4. So we have negative 2 times 3.2 times 6.4, and then we cancel out on the right. So now we have cosine B is equal to all this on the left, which would be 7.6 squared minus 3.2 squared minus 6.4 squared, and all over negative 2 times 3.2 times 6.4. A lot of writing involved, isn't there? And then we finally isolate B by taking the inverse cosine of both sides of this equation. So I put cosine negative 1, and what we have left is, I'm going to move the B to the left side. B is equal to the inverse cosine of 7.6 squared minus 3.2 squared minus 6.4 squared, and that's all going to be over negative 2 times 3.2 times 6.4. And now we go to our calculator. Here it is, T-Inspire CX calculator. We see over here in our view screen that we are in degree mode. See that little degree right here. And so we can go to take this, to do the inverse cosine, we press the trig button and go over here. So we get our fraction. We have 7.6 squared minus 3.2 squared minus 6.4 squared, and all over negative 2 times 3.2 times 6.4. You kind of just check everything, make sure it's right. Press enter. We get 99.216 degrees. So B is equal to 99.216 degrees. Okay, so that's going to be one thing. Next, well, we can find our other angles by similarly using the law of cosines. We can find angle C, big C, angle big A, but probably using this type of solution method, the easier thing to do would be to use the law of sines. And so we're going to solve for the smallest angle first from what's remaining. So I'm going to put sine of this angle A, which we do not know, is over 3.2 is equal to sine of angle B, which is going to be sine of 99.216 degrees over side B, and side B is 7.6. If we cross multiply that 3.2, so I'm going to take this 3.2, bring it right over here. We're going to have sine A is equal to 3.2 times sine of 99.216 degrees over side B, which is again 7.6. And now to undo this sine, get the A out of the sine A, we take the inverse sine of both sides. So I'll put sine -1. And what we get left is A is equal to inverse sine of all this, which again is 3.2 times sine of 99.216 degrees over 7.6. And now to the calculator, we have the trig button. We're going to go to inverse sine of make sure we have it right here. 3.2 times sine 99.26. Okay. So 3.2 times sine, and what I'm going to do instead of putting in 99.216, I'm going to press Control negative sign, which gives me ANS, which is the last number calculated, over side B, which is 7.6, and we get this angle, 24 point. We'll round to the thousandths place also. We'll call it 24.558. Notice it's 99.215, 9656, 4301, out to several decimal places because that's an exact version of this 99.216 up here. So anyway, we'll put 24.558 degrees. So that's side A. And the last thing we have to do is find our remaining side C, and C is going to be equal to 180 degrees minus, we have 99.216 degrees minus 24.558 degrees. So C is going to be equal to, we go to our calculator again, we have 180 minus 99.216 and minus, I'm going to go Control ANS, last number calculated. So for this we have 56.226 degrees. So 56.226 degrees. Now, what I'm going to do next is still stay on the same problem 11, which we've now totally solved, but show a feature on the T-CX calculator called NSolve, or numerical solve. And so I have the same equation written as I had in place earlier, but now I'm going to go ahead and enter this into our NSolve feature, and to do that, you're going to see a lot less writing here. We're going to go press menu 3, 1 for numerical solve, and we just enter the equation. So we put 7.6 squared equals 3.2 squared plus 6.4 squared, and we have minus 2 times 3.2 times 6.4 times cosine, we'll call it x. You can use letters other than x, but I'll call it x. And then put comma x. So you just check, make sure you have everything entered properly. It's really easy to make a mistake. So I think everything is in place. We press enter. We get 99.216. Where have we seen that before? So we go over here and we say B 99.216 degrees. Okay, a lot less writing. And then we can do the same thing for the other angles. So we can solve for angle C. So we have 6.4 squared equals 7.6 squared plus 3.2 squared minus 2 times 7.6 times 3.2, that's 3.2, and that's going to be times cosine angle, what is, where it goes, 6.4 angle C. And so we go to our calculator again, and this, we're going to numerical solve, menu 3-1. So we put in 6.4 squared equals 7.6 squared plus 3.2 squared minus 2 times 7.6 times 3.2 times cosine we'll call it cosine C. We'll just use the accurate number here. We go over here and put comma C, and we get as our answer 56.226 degrees. I think we've seen that before, haven't we? 56.226 degrees. And now we can just subtract from 180. That might be the easiest thing. Or we could just put in 3.2 squared equals 7.6 squared plus 6.4 squared minus 2 times 7.6 times 6.4, and that's going to be cosine angle A. So now we go to our calculator again for the third time, in solve menu 3-1. We have, oops, there we go, 3.2 squared equals 7.6 squared plus 6.4 squared minus 2 times 7.6 times 6.4 times cosine A. Go right here. We can put in comma A. And there we have our final angle, 24.558 degrees. So and then we can add all these up, make sure they total 180 degrees, as they should. Now, if you just compare methods of solving and what actually had to be written down, this one here versus the back page here, you'll see a distinct difference. Okay, let's go on to problem 13. Well, here, if you just take a quick glance, do we have a side situation? No. Do we have a side angle side? No. We have like a side, not a side angle side, but we have on the opposite, we have angle A, which is 42 degrees, this opposite side A, which is 7. So this really is going to be a law of sines application. And so for that, we can write this as sine of angle B, which we don't know, over side of angle B, which is 10, is equal to sine of angle A, which is sine of 42 degrees, over side A, which is 7. And cross multiplying that 10 to either side, we have sine B is equal to 10 times sine of 42 degrees over 7. And taking the inverse sign to solve for B, we have B is equal to inverse sine of all this, which is 10 times sine 42 degrees over 7. Okay, and now going to our calculator. Inverse sine and we have 10 times sine of 42 degrees over 7. And there we have 72.921 degrees. Okay, so that's angle B. And to find angle C, I'm just come to the left here, we have angle C is going to be equal to 180 minus our 42 degrees minus our 72.921 degrees, and that's going to be equal to, on our calculator, 180 minus 42 minus, I'm just going to do the last number calculated, which is control negative sign A and S. So we get 65.079 degrees. So we have angle B, angle C, and next we want to find side C. Well, side C over sine of angle C sine of 65.079 degrees equals, we'll have A, side A, which is 7, over our sine of 42 degrees. And so cross multiplying, as we've done consistently here, right, we have C is equal to 7 times the sine of 65.079 degrees, and that all over sine of 42 degrees. And so C is going to be equal to, we go to our calculator, we have 7 times sine, and I'm going to use 65.079. I think I'm going to do Control ANS over sine of 42 degrees. So we get 9.487. So we have side C, we have side B, angle B, excuse me, and we have angle C. Now, as I did for problem 11, I want to go to use numerical solve. I have the equation set up, so we're just going to use numerical solve and take this equation here, sine B over 10 equals sine 42 degrees over 7. So we go to menu 3.1, and we come in here, this we have, make sure I get this equation right here, sine B over 10 equals sine 42 degrees over 7. Sine B over 10 equals sine 42 degrees over 7. Go over here, press our comma, and we're solving for this letter B, and for that we get 72.921 degrees. And again, we could do the same thing as we did in that problem earlier. The other method, we take 180 minus 42 minus 72.921. It's 921 degrees, and let's see, that's going to be angle C. Right, that's B. Okay, good. So we can go to our calculator, and we already calculated this earlier. 65.079 degrees. So that's going to be angle C. So we have angle C angle B. The only thing we lack is side C. I'm going to do that just for exhaustive purposes. I'm going to take this little c over sine of 65.079 is equal to this side A, which is 7 over sine of 42 degrees. And again, we're going to go to numerical solve. So here we are. Menu 3.1. We have side C, which we do not yet know, over sine. I'm going to take the last number, not the last number calculated, because we're going to take this 65.079. And that's going to be equal to 7 over sine 42 degrees. And we go over here and press comma C. And our angle C is going to, our side C is going to be 9.487. So 9.487. And you can see we got practically the same answers we got here for the other method. You can see a little less writing here for problem 13 using numerical solve. And the last one I'm going to look at in this set I'm going to work out is problem 15. In this case, we have a side, known side opposite a known angle, and then we have that side. So we're going to set up the law of sines, and to do that we're going to say, okay, sine of angle B over side B is going to be equal to sine of 63 degrees over 8.6. And as we've done earlier, cross multiplying, we have sine B equals 11.1 times sine 11.1 sine 63 degrees over 8.6, and taking the inverse sine of both sides of this equation, we have angle B is equal to inverse sine of 11.1 sine 63 degrees, and that over 8.6. Yeah, it's 8.6 there. Okay, so now going to our calculator, we go to inverse sine. I want to make sure I get this right here. We're going to have 11.1 sine 63 over 8.6. Degrees over 8.6. And what do we get? We press enter. Looks like you're right. Undefined. So something is wrong. This does not compute. Well, let me show you something here. If we take this 11.1 times the sine of 61 degrees, and we put that over 8.6 and calculate this, what do we get? We get 1.129. Okay. Now, since (11.1) sine 63, I said 61, didn't I? 63. It's going to be the same thing anyway. I'll find out what it is. I wonder if I can just change it like this. No, it won't let me do it. (11.1) times sine 63 degrees over 8.6. Okay, 1.15. Okay, same thing. It's approximately 1.15, with since and is greater than 1, inverse sine of 1.15 does not exist. Therefore, 3 dots, not a triangle. See, to get this number under 1.5, 1.15, or under 1, this number in the denominator would have to be somewhat bigger than 8.6. So that's going to be our answer for problem 15. And I messed up a little bit by using in the calculator 61 degrees, but the end result is still the same. And here we have problem 16. Try it out like problem 15. See if you're going to have the same type of setup. See if you have a triangle or not. Anyway, good luck on all these even number problems. And as always, thanks for viewing.